Moises. I come from UTB, representing the Physics and Astronomy Department. I'm president of the Society of Physics Students. And here are my friends. So come on, guys, go ahead and line up. Go ahead and line up, everybody. And I'm going to jump on stage. And everybody go ahead and line up right here for the table. And in the physics department, we have something that's pretty unique. We all come from different places, from even some of us from different countries. And myself, I'm from Los Fresnos, here from Los Fresnos, Texas, next town over, right next to Brownsville. And now I'm working on my master's degree in physics. And a lot of us here are actually physics students, and some are special friends of ours. So I'm going to pass down the microphone, and everyone's going to introduce themselves. So here you go.
Hi, I'm Luis,
Hello everyone, my name is Ayo. I'm from Nigeria, Africa. I'm a master's student in physics students at UTB.
Hello everyone, I'm James Santiago and I come from China and in physics. I believe our show will going to make you explore your mind. Feel great, okay? Science will make the world better, trust them.
From Burlington, so I'm glad to meet you all. Hope you all have a good time.
Hi, I'm Erin Pearl. I'm from Brownsville.
Hello, my name is Andres. I come from my mother.
Hi, my name is Moises. I'm from Los Fresnos. I'm just kidding, guys. So we also have two more people. Our cameraman right here, his name is Martin Diaz. He comes from his hometown is Piedras Negras, correct? Yeah. And over on this side, we have our great advisor. His name is Robert Stone, and he's born and raised in Brownsville, correct? He's from Brownsville. Alright, so let's get started, shall we? So here we have our friend G. G is he has this balloon and he has a pump. Now, who can tell me how a pump works? Let's hear it. Let's hear it.
Ladies and gentlemen, we raise our hands and wait.
Oh, it's okay. It's very interactive. They can go ahead and shout it out loud. So go ahead. Okay. So now, let's see what happens. He's gonna, what's going on? This is good? Okay. So go ahead and start putting air. So we'll see what's going on is the pump gets air from around the atmosphere, right? Now, the pump starts pushing the air into the balloon. Now, the balloon has some properties of elasticity, so it starts stretching. You see? Now, it's getting filled up with air. It's getting filled up with air, and what do you think is going to happen if it keeps on filling it up with air? It's going to pop. All right, so now you guys should be aware that there will be a pop, right? So let's get ready. Keep on going. But we never know when it's really going to pop because, we're pumping the balloon and alright, so then what happens? It pops. Why did it pop? Now, here we have something special. It's a 2-liter bottle. Now, in this 2-liter bottle, the 2-liter bottle also has some elasticity properties, right? So it can only stretch so much. We can show the same effect, but this time with special gas. Well, it's actually a liquid, a special liquid that we have in a special container. And here it is. Have you guys ever heard of liquid nitrogen? Yes. What's so special about liquid nitrogen? It freezes things. You guys know how cold it is? It's minus 273 degrees Celsius. Minus 273 degrees Celsius. So what they're doing is they're filling up this bottle with some of this liquid nitrogen. The liquid nitrogen evaporates. The liquid nitrogen evaporates at room temperature. So here, I do have to say that you have to be careful with this. It's very cold, and this next explosion is going to be really loud. So guys, be ready. This is really, really loud.
So you're not so close. Cover your ears.
Cover your ears.
Okay.
So, here's your this is all that's left. This is all that's left from the explosion. So this is very dangerous, right? Now, this sort of things you shouldn't try at home. Now, I always start off by asking, who here is interested in science and math? That is a great response. Now, I do see some hands that didn't go up. I don't know, maybe you're shy or maybe you're not that interested, but I really hope that you really enjoy the show and that I change your mind and you do become interested in math and science, because that's always sunny here. So right now what they're doing is they're pouring some of the liquid nitrogen into a larger container, and they'll bring this container right out. Now you'll see that, remember, it's minus 273 degrees Celsius. So when you see it, it's actually evaporating. So the very first thing we do is we'll grab a banana and we put it to cook. Alright, now how do you know when something's actually boiling? So have you guys seen a tea maker before? So how do you know when the tea's ready? It makes a noise. So let's see if it does the same thing here. Tea's ready. All right. So we saw something blow up with the liquid nitrogen. So now I have a balloon. What do you think happens if I put the balloon in the liquid nitrogen? Wait. What's going on with the balloon? So the air is freezing, it's losing air, maybe it has a hole. Let's see what happens. So the air is coming right back. Here we have another balloon. Let's see, maybe there was something funny with this balloon. Maybe that balloon will do something. It's frozen, you can hear it. Hear the crackling? Oh, okay, there we go. So there we go. Now the balloons go back up. Now how is this possible? What's going on? So inside we have all these air particles. They're moving all around. They're going in all directions, right? Now if they get cold, they do what we usually do when we get cold. We're inside. We're nice and warm. So we go outside and it's very cold. We get all close together and we start, getting really close together. That's exactly what happens with the air particles inside the balloon. So here we have some flowers. Let's talk to Mr. Flower real quick. Mr. Flower, what do you have to say? Oh, he doesn't really speak. So let's see what happens when we dip them in liquid nitrogen. Now let's squeeze the frozen one. So what's going on? It's freezing. How's the water freezing? Flowers have what's called a high water content. They contain a lot of water inside of the petals. So whenever we dip it in the liquid nitrogen, which is really cold, it gets frozen. It gets so frozen and that it gets brittle. It gets very brittle. That way, whenever we touch it, it breaks. It almost seems like glass. So go ahead and smack it on the table. See what happens. So we saw something blow up, we saw something freeze, and break, it's boiling, and now we have a piece of wood, you know. Maybe sometimes you want to do some woodwork in the house, maybe you want to make a birdhouse. You find some wood, you find a nail, and all we have is a banana and some liquid nitrogen. Fortunately, we forgot our hammer, but I think we might be able to use this. I'm not sure. We've tried it a couple times, but let's see what happens. We have a banana that we've had in the liquid nitrogen since we started, and it's real. It's a real banana, and here it is. And let's see what happens. It's as hard as a rock. So now you know. If you're in the wood shop and you need a hammer or something, you can use a banana and some liquid nitrogen. All right, and yeah, it is a real banana. All right, thank you guys. So now here we have some more liquid nitrogen. Now it comes to my favorite part of the show. My favorite part of the show is what happens if you mix something that's really cold with something that's really hot. Oil? Yeah. A tornado? Well, let's see what happens. Now, what we're going to do is we're going to set up a container down here. Let's see. We have our container down here, and we're getting it ready. And let's see, I'm going to come down here. Now, I have some water that's been boiling ever since before